We are here at the Imnaviate Creek to measure the snow melt. I have a corer that measures the snow water equivalent of the snowpack.
Snow melt sounds like it's simple to measure, and you can just put out a stake and watch the snow melt down the stake, but that wouldn't really tell you what's happening 10 meters away, this to the left or the right. So you really have to watch the whole basin.
Well, there's pretty much nothing in there. And then I put the corer in the snowpack and I shout the depth to my field assistant. 42.
My name is Sky Sturm. I'm an architect in Fairbanks, Alaska.
We know that we have 42 centimeters of snow. Now we weighed it, so we will know how much water is in there. So we grab this, dripping a little bit because it's melting. Then we plug this puppy out.
Try to make it so it doesn't blow so much too. 169, still 169.
That's about it.
Imnaviate Creek is a long-term watershed study site. It's got a little creek and a nice well-defined basin in which you can study the hydrology, because hydrology you actually need to not only look at sort of what's on the landscape, but what flows out of the landscape, so you actually need a nice little stream. I guess in 1984 studies got going there. It's where they watched the snow melt and the runoff in a nice small Arctic basin. And those have been continued ever since. It's the longest continuing and ongoing record of snowmelt and runoff.
It's one of the few places that we actually know from thorough measurements how every spring the snow is disappearing in the Arctic. And so it's kind of a privilege to be here and every day contributing to this data set.
My father is Matthew Sturm. He's a snow scientist, so throughout my whole life actually been part of snow studies all over Alaska. And so here I am in the Imnaviate Creek watershed, basically a field assistant gathering data for a spring snowmelt study.
This is a snow probe. It's an automatic snow probe that measures snow depth and GPS location at the same time. It's called Magna probe.
So you press it down and the basket stays on the top of the snow. The point hits the tundra. Press a button and it will record, because it's connected to a GPS, it will record at the same time the depth in centimeters of the snow and the GPS coordinates. Yay!
There's a 1 kilometer traverse line, and every day they get out and they measure the depth at about 1,000 places along that line. Then they'll go and they'll core, and they'll take the core and they'll weigh the core and they'll figure out how much water is in the snow for a given depth. So now we'll know at a very large number of places across this line how much water is remaining there. And then we'll take photos to get the aerial distribution. Where is it bare and where's there snow still? For this large basin, we'll know sort of how much is already melted, how much remains as snow. And then of course we'll look at the stream flow and we'll say, well, how much has flowed down out of the basin, which in theory should equal what was melting, but there's also, of course, what's going back into the ground. It's repetitive. You just do it day after day and watch what happens.
What is in the stream, it comes from the snowmelt. So we are collecting over kilometers at least 1,500 values of snow depths. So we're actually characterizing snow cover in a fair detail that presumably hasn't been done before during the snowmelt. So it would be nice to see how the characteristics of the snowmelt that we get from our measurements of snow, they correspond to the characteristic of the snowmelt that we'll observe in the creek.
We packed food for a month. We'll be here from when the snow was 100% to when it's gone. Since we've been here 10 days and we're at 50%, we might be here another 10 more.
Last year we came here on May 15, I think, and we didn't have to shovel any snow to get into the Silver Bullet. Whereas this year we came out May 23 and we had to shovel to get inside because there was like a big drift formed just by the door. So yeah, the snow was significantly different this year.
Right now, the way the world sort of looks and decides there's a trend in Arctic snowmelt is we lose satellites. And when we're looking at such huge swaths of country and we're doing it with a satellite, I would question whether we really know what's going on. We have a number, but how do we interpret that number? And that's still an issue today. So rather than hypothesis-driven, we need a ground truth spot where we can look at these large-scale products and compare them to what we actually know is going on and refine our interpretation. In particular, the science looks like this. Models we run to look at climate and hydrology now ingest what's called snow cover area. Well, snow cover area is literally like looking down on a map and asking whether it's black or white. It tells you absolutely nothing about the depth. We do that because we can't get the depth very well. So we use the snow cover area as a proxy, and then we wave our hands and we say snow cover area somehow is related to the amount of snow, the volume of snow. But in fact, these are not related in a simple way at all. And we gloss over that. But at a place like Imnaviate, you can actually explore whether the snow cover area and the snow volume, the mass of snow, the actual amount of water, are truly related. And you can explore that relationship and then see if at the global and pan-Arctic scale, we're applying these correctly. So I call it a reality check. That's what I really call it.